Mike, you muted.
Oh yeah, sorry, I'm just mumbling to myself.
Oh, okay. So used to seeing lips moving and that meaning that someone's trying to say something that no one's hearing.
Actually, let me double check here. I think since Kim and some of the other folks are out, I think I might be the one running the meeting. Let me just double check. Did I agree to it? Yes. Okay. So yeah, we'll give it another minute or two for a few more folks to join, and then we can get started. Oh, true. Yeah, I did. It's been a long week. Let's see here. Okay. Whoops. So we can get started here. So I'm gonna post here are the notes. Put your notes in the agenda here. And then while that's going on, just a reminder here, the meeting is being recorded and will be uploaded to YouTube shortly thereafter. So, and also, your participation in this meeting abides by is an agreement to abide by the OpenSSF Code of Conduct. Okay, cool. So we can get started with the agenda here. Usually we start off first just sort of asking, is there anybody new to the meeting who wants to introduce themselves?
Hi, I'm Brad Beck. I'm with the city working on the secure software factory there and also as part of the OpenSSF project too.
Cool. Glad to see you.
I'll go. Hi, I'm Patrick Flynn. I'm a recent Chain Guard employee and just coming to check out SLSA and find out more about it. Thanks.
Welcome.
Likewise, my name is Jason Lutz. I'm a relatively new Chain Guard employee and definitely checking out the SLSA framework.
Cool.
Mark Sturdivant. I work at IBM with some folks that you've probably met here already. Been working on security just recently.
Hey, I'm Josh Mullican from Red Hat, checking out SLSA and trying to learn how we can integrate it kind of here with how we do things at Red Hat.
Cool. All right. I guess we can get to the agenda now. Glad to see so many new faces. Mark, you're up first.
Thanks. I just wanted to point out, in case not everyone is subscribed to the other repo, the Salsa proposals repo. I sent out the project roadmap that I had presented 2 weeks ago, which is in text form. Right now, it just contains things that my organization, Google, is working on. It doesn't represent any other projects that the people are working on because I'm not aware of them. So if the overall road, like if folks agree with the overall direction and how it's presented here, we could have subsequent pull requests to add other parts of the roadmap or other kind of committed work to the roadmap. But hopefully, I put in the Salsa roadmap to, or like in the proposals directory repository, so that way it's kind of a point in time snapshot of where we're headed. But I don't think once it's kind of accepted, we'll just like leave it as this was the plan as of May 2022. That's it for me.
All right, cool.
Sean is next.
Yeah, I realized I did not make the document I linked here public until this morning, so I'm guessing not a lot of people have had a chance to have a look at it. Yeah, I didn't want to create this just as a GitHub issue because the explanation in there is somewhat lengthy and a little bit too much for an issue on its own and probably not suitable for a proposal either. But I figured that as we were getting towards finalizing a Salsa 1.0 specification, it would be good to open up a discussion that we've been having internally, at least, on reproducibility. Specifically that we're finding that reproducibility for certain ecosystems is just not a possibility. We'll go into why a little bit here. If I can just share my screen here. Okay, so our take on Salsa here is that there's a lot of things in Salsa which will help make a build system tamper-proof, but none of it is guaranteed. And so what Salsa is really giving us is a measure of tamper evidence within a build system and within a supply chain. And so there are certain requirements that are somewhat more catch-all. And reproducibility, I think, is kind of the ultimate catch-all here, in that everything that's not specifically covered by Salsa in terms of what you can attest to and everything else, so everything kind of below that layer, even in the software supply chain, so even down to the hardware that things run on, Salsa doesn't make any specific attestations on it. And bitwise reproducibility is kind of a proxy for tamper evidence in the parts of build systems that are not covered by Salsa elsewhere. So it gives you, as a benefit, it gives you some measure of whether or not the whole, of the supply chain, even the parts that aren't covered by Salsa, have not been tampered with. But certainly for some ecosystems and some underlying build systems that you'd end up bootstrapping, bitwise reproducibility is not a good measure for the overall tamper evidence in a build system. One key reason that we find is that looking at a lot of ecosystems kind of artifact formats, so if we look at Python's wheel format, Java's jar, Ruby's gem, these are all usually variants of or subdialects of tarballs or zip files. Tarballs and zip files usually contain timestamp and metadata information on the files that they've packaged up. And so you literally cannot produce a bitwise, even if all of your inputs are the same, it's almost impossible to generate a bitwise identical wheel or gem or jar file from two runs, even from the same source. So, I've just been testing this again this morning. I just tried, from a pure Python module, 2 runs of pip wheel dot in the same directory with the same source files on the same machine produce different wheels. And that is purely down to the timestamps. You could get around this to a certain extent with some versions of tar and things like that by flattening all the timestamps and specifying what a timestamp should be. But that doesn't really work because some artifacts rely on the internal differences in timestamps on files to actually work correctly. So, for example, if you make a tarball of something that's an intermediate step, like if you take a C library and you do a make all, you tar that up, take it somewhere else, and then do the make install somewhere else. If you flatten the timestamp, the make doesn't know which artifact came before which other ones. So you end up with .c files and .o files with the same dates on, and make doesn't really know what to do with them. So there are some ecosystems that require relative timestamps to be preserved at least. Underlying that, then, if you end up with being dependent on relative timestamps, you can't end up really being able to reproduce these things unless you've got like a real-time operating system on dedicated hardware. There's no way you're going to be able to guarantee the relative timestamps within an artifact. So that's one of the things that we're finding, is that even if we run the same build system twice, we don't get the same output. There are other things that can affect the output of artifacts, even when we're not talking about aggregate artifacts like tarballs and zip files. The actual hardware that things run on actually has an influence on the output. So running the same container in the same cluster, but on different hardware, can sometimes produce different artifacts. So yeah, the examples here are whether or not you've got a GPU core available and which version and stepping of the GPU core, which version and stepping of the CPU core you've got. You can end up with different output for different builds or for the same build. So even different steppings of the same CPU can end up with different builds, especially in terms of things like TensorFlow that take advantage of all of the potential optimizations that the CPUs can use. Yeah, and I laid out here, there are some other conditions that potentially affect reproducibility. It's possible that things like load on the machine that's actually hosting your container may actually affect the output, because you may end up with different compiler strategies based on the available memory that you've got. You may end up with different thread ordering in execution. Some of these things may affect the output of compilers. So a problem really with this is that although even though SLSA level 4 specifies that reproducibility is a kind of an optional requirement, it does make a requirement that you specify why any particular build is not reproducible. And I think what that's going to lead to is a bunch of basically blanket get out clauses for reproducibility, as in this would be reproducible, but it's Python and we've made a wheel. This would be reproducible, but, and basically you count out entire ecosystems from being able to produce this. And so that each ecosystem that can't do this will end up needing kind of a blanket exception for reproducibility. Now, I'd love to be proved wrong on a lot of these things, but it's been our experience that the things that we're building at the moment, so mostly Perl, Python, Tcl, Ruby, we cannot produce bitwise identical builds on subsequent runs of the same, with a hermetic build system, exactly the same containers, exactly the same build conditions. We still cannot produce bitwise identical artifacts. So yeah, this is really opening a discussion on whether or not we should find a better proxy for build system tampering than purely bitwise idempotency, or whether we can find a better way to actually, if we can find a better way to kind of improve the ecosystems that currently can't produce reproducible builds. So with that, I'll kind of open up the discussion a bit.
So I think part of, sorry, Mark's got his hand up.
Yep.
Go, Mark.
No, go
Marcus.
right ahead.
I was going to say, I think part of the problem might be in the caveat, which was the things we're trying to build today. Like a lot of modern Python, Python 3 has a very volatile build ecosystem, but if you're building with, I don't know how recent, but recent versions of the build tools, like you can get bit for bit reproducible wheels. And so I would guess the problem is like old inputs and old tools in use.
Well, I just tried this morning with 3.10.4 and could not produce the same build, the same wheel.
Interesting. Okay. I guess we shouldn't dive into debugging your build system right now. But I think like from where I'm standing, this has been a relatively solved problem for 10 or so years. Like the reproducible builds project has established standards which toolchains implement, and the number of, for example, the number of packages in Debian which are bit for bit reproducible is fairly significant, in the high 90th percentile, I think. So I don't know that there's a strong case here for removing it, but that's just my perspective from the kind of
Yeah, I would
distribution.
love to be proven wrong on this.
Yeah, I'll let Mark talk. There's been a few links dropped in your doc on some of the things I'm talking
Yep.
about anyway.
I think what, like Sean, you point out, is that although there are ways to make builds deterministic, it's expensive.
Mhm.
Like, yes, you could strip timestamps, you could make sure the zip files are ordered in some deterministic manner, you could blah, blah, blah. Like the fact that Debian doesn't have 100%, but only like 90%, is, I think, indicative that it's not too bad to get the majority of packages, but I think we should consider cost and like the cost benefit, like the return on investment from requiring things to be reproducible. I don't think we should discount the cost. The reason it was added, because you said it as a proxy for tamper evidence, I think is a phrase used. So originally, just kind of as a background, this was not in the requirements. This was added. David A. Wheeler had suggested adding it as a recommendation, and I think it's a good thing to think about for one. I agree that it's good to think about for 1.0 of like where and how we should fit it in. I don't really have an opinion right now of like whether it should or shouldn't change. I do think it's a good point that we should discuss. I think the intention of it, at least from my personal point of view, is that reproducibility is valuable because it makes it very easy for forensics and for like you said, I guess that's maybe what you're saying by tamper evidence. And also it makes it easier to build where it can enable, although this is speculative, like a SLSA 4 build system by having, if two independent things build it, then you kind of know, you get a lot of properties out of that if you have a whole verification system in place. So I think there's also some nice properties in like the bit for bit identical is just like easy to compare. But I feel like there's maybe room that we could like better define what that means. Like something to perhaps that we could consider would be like if it's not necessarily deterministic the first time, but to reproduce it, you kind of use these non-deterministic or like these non-hermetic inputs, and subsequent rebuilds could use the same timestamp or something. That seems okay to me, although that probably is just as expensive to do as making it fully deterministic. So I don't know if that's actually of any value. Anyway, does anyone have any other thoughts?
So my thoughts here are that reproducibility is still very important. And even if like it's the only SLSA rule that has an easy escape of you just explain why you don't have the capabilities to do it. So again, if the catch-all escape was, well, the whole NPM ecosystem, whether it does or not, I don't know. But as an example, if you have to say the whole ecosystem is non-reproducible, then there's your reason. I think that, you know, if you can only get so much trust in various different build servers, and if you want to have less trust in them, then you can just build on many servers and hope for a quorum or look for any kind of outliers, you know, that kind of thing. It's there's a lot of big advantages with reproducible builds, and there's a lot of work being done by a lot of people. So it's not like, you know, everyone will just be on their own trying to achieve reproducible builds on their own. You know, there's a lot of help out there. There's a lot of work that's been done in the past, and I think it's a key part, especially of level 4, which is meant to be advanced. And when we start talking about the cost of implementing some of this, that there's already quite a big cost in some of the SLSA stuff. You know, if you're doing massive amounts of builds at a massive scale, you got to store a massive amount of provenance. You know, each individual file might be small, but you know, you want to start maintaining this. You're going to want to set up ways to query this historic provenance to look for stuff, and that's completely ignoring like adding in SBOMs and wanting to do queries on that. And you know, there's a lot that goes into SLSA, especially at level 4. So that's my 2 cents.
Yeah, I agree that it's expensive to do, and you know there is a lot of expense in producing something that comes up with all the other requirements of SLSA 4. Yeah, and I'm certainly happy to take a look at any efforts that that are out there for the ecosystems that we're trying to build, to help make them reproducible. And I think reproducibility is a good thing in a build system in general. But by and large, what we're doing here is bootstrapping someone else's build system, and quite often they haven't had reproducibility as one of their tenets from the outset. So it's kind of difficult to impose reproducibility on these things over the top. Mark, you have your hand up again.
Yeah, I think that like to scale this in order like to actually cover a significant number of packages, it kind of has to be done at the infrastructure level. So individual package maintainers shouldn't have to do anything. Like for the Python case, I think the right solution for reproducibility, whether or not it's a formal SLSA requirement or not, I think it would be valuable to spend some effort trying to make all Python packages reproducible by default with the default tooling. And like you have to go out of your way not to do that. Like within, like for example, Bazel is reproducible like by design. They originally did it for like performance reasons, so that for caching, but we also get the security benefit out of that as well. And I think if individual package owner had to do work to make it reproducible, it wouldn't happen. So I think that's the only way we're going to actually make any inroads here.
Yeah, fair enough. I mean, yeah, we see that same sort of thing, and we could specifically call out Go and Bazel as something that as things that have that reproducibility baked in from the outset. Yeah, I think it's just tough to impose already on an existing ecosystem. But yeah, I agree that efforts to actually improve ecosystems that are in place already to get to this point would probably be the easiest way to solve it. Michael.
Yeah, just to add on to what Mark was saying, yeah, I think this is sort of what products like Alpha Omega are really also useful for here, is like to kind of come in and say, hey, can we go to something like the Python ecosystem and say, we'll spend some money to make your build ecosystem reproducible, or so on. I think that's going to provide a lot of value, because like I know there's a lot of systems that try to sort of build on top of stuff and do a lot of things, and sort of patch things and strip out timestamps. But in a lot of ways, I think long term it's going to be cheaper the more we can kind of go back to, hey, like working with the actual language maintainers, the ecosystem maintainers, and so on.
Okay, who else was it? Joshua, I think.
Yeah, Mark just preempted me in the Docker bit, I think, but I was going to suggest, like there's been some discussion about higher SLSA levels and the fact that this is currently, as you've articulated, fairly hand wavy with a big like get out hatch. Might be a reason to put this in a higher level if we're going to have higher levels in the first version of the spec, or at the very least, this deserves some consideration in how it's phrased and where it sits in the ladder. I do genuinely believe this is like a worthwhile goal. We had some pretty good success in a project I worked on in the past, taking 700 or so packages from random ecosystems and making them reproducible. So I know it is possible, but I also do fully understand that it is a lot of work that most people don't find very interesting.
Aaron.
Yeah, I was gonna just comment it. So, within this conversation, it seems like the reproducibility across different ecosystems is difficult today. It seems like, unless there's a driver behind it, who's gonna wanna take the time to do that right across an ecosystem, the security benefit for reproducibility is, I see it as massive. So I think SLSA is very defining that, and that's gonna actually drive these different ecosystems to want to take that priority. So I think this is great to keep that for sure.
Hey, Jacques.
Helps if I mute myself. I'm just going to drop a link into the chat. There's a spreadsheet that's been developed. Why won't the lower hand button actually lower my hand? There we go. There's a spreadsheet that's being developed in the securing software repos working group that you were at yesterday, where we're looking at like different features that different package ecosystems have. One of the line items is reproducibility. I think one of the reasons that it hasn't been on the radar, apart from it's not a thing you think of naturally until somebody points it out, is also that most package registries or repositories behave immutably. Once you've consumed a package at a version, it's consumed for good. Mm-hmm. So there's no concept in the repository of reproduction. It only happens at build time. And it's an error to like reproduce, so to speak, and try to upload. Like it doesn't, within the context of the server, make any sense. So I think that's the other reason it hasn't happened before.
Yeah, I mean, just coming back to caching a little bit, I mean, we kind of fake this up by, if you give us the same requirements, we give you the same build plan and hence the same artifact, and we just draw that from cache. So it looks like we're doing it, but it's it's caching. It's not really, we can't reproduce these builds directly. Yeah. And I think if comparing output of builds, you probably need at least 3. One to detect, just to detect an error and work out which one is more likely to be, minority report style, whether or not you've actually.
I'm still listening, but my door is ringing. I'll be back in a second.
Okay. Yeah, so it's so we can fake these things with caching, but yeah, and again, the other, the philosophical question is, if you've got 2 build systems that produce exactly the same output based on the same input, are they logically not the same build system? And hence, not necessarily worth the comparison. Mark, you have your hand up.
Yeah, one thing I maybe wanted a quick question, because the title of your doc is verifying reproducibility. Mm-hmm. Are we all interpreting the requirement the same? Does the build system actually need to verify that it was reproduced, like by actually building it twice and checking? Or is it just simply a claim that I think this ought to be reproducible, So someone should be able to try, or I'm explicitly claiming, no, I know it's not reproducible for this problem.
Yeah, I mean, I think it's just about the claim.
Okay. I've interpreted it.
And the fact that we're specific about it being kind of bitwise identical, because we don't have a better measure of functionally identical.
So just to jump in on that quickly, because David was the original person that introduced this requirement at SLSA level 4, and he's also filed an issue on the SLSA repository about introducing verifiably reproducible builds at a higher SLSA level. So I think that how you summarized the state is correct.
Jack.
Yeah, just one comment on the separate build servers and whether they're different and such. So typically, once you get a reproducible build, at least on your machine, you'll then start introducing kind of things that cause the builds to be different. So if you look at the Arch Linux reproducible builds, they'll build stuff with a POSIX shell from Bash, and they'll also build stuff with a POSIX compliant shell from Dash. You can introduce other kind of forms of stuff that usually sets your build off in unstable paths with like an unstable file system, and quite a lot of this is listed in the reproducible builds kind of wiki and such. So once you get a reproducible build, you then start testing that to the extreme by introducing this kind of disorder, this kind of stuff that will then tease out things that are in fact not reproducible across machines.
Oh, that's interesting. I will go take a look at the wiki. Okay, no other hands up. Yeah, hand it back. Michael, take it away.
So I think next up is Josh.
Hey, sorry, was typing. I can't multitask apparently. So I just wanted to highlight this really for a similar reason that Mark did his notes, because there's a discussion happening in a separate repository about the switch to the community specification license and how there's some misalignment between how the SLSA community governance is arranged and how the community specification license expects governance to be arranged, I think. So I just wanted to highlight the issue that I've included in the doc and ask people to take a look offline and try and figure out what, if anything, we need to do there. So especially, I guess, steering committee folks, but really just everyone that's interested. Could use some participants in the conversation so we can figure out what we need to do and move forward with this.
Well, yeah,
So
yeah, it's up. Oh, go ahead, Mark.
Oh, sorry. Is this simply changing the text to match what we already have, or is it a requirement from like OpenSSF that we restructure to match what's in the text?
That is a great question, one that I share and didn't have a chance to find the answer for before this meeting, unfortunately.
Yeah. There's also a couple other projects that I think are having similar sorts of concerns here. I think we're trying to also like get a few folks from OpenSSF and Linux Foundation and just kind of, verify some of that.
I think I just want to add one thing I did comment on in the issue is that one of the things in the community specification license suggestion is that we have explicitly named kind of maintainer and editors. And I do feel like we've grown there's some distinct, like there are people who are working on effectively maintaining the specification, right? Mark is a great example of that, who long-term investment in the project, I think should be recognized by some kind of formal role, whereas the steering committee is was imagined to be rotating and provide like a more balanced set of reviewers for kind of project direction, but I do think there's distinct roles that it's worth codifying. So even, yeah, even once we've answered the question, I still think there's something to think about here.
All right, cool. Oh, Jacques?
I don't know if we went through the process of adopting the draft charter that the OpenSSF were asking folks to do a little while back before the governance review got more involved. It does talk about maintainers quite explicitly, and the idea of a steering committee who are composed, or which is, sorry, composed of those maintainers. So it seems like there's some overlap there.
Is part of the confusion here, and I'm not very familiar with the OpenSSF charter, so forgive me, but as I understand it, SLSA is a sub-project of the Supply Chain Integrity Working Group, so that has its...
It's a good point. Yeah, that would be where like charters are handed out, but part of my understanding of, it's kind of tricky because there's things that are like capital P projects that directly hang off the side of the OpenSSF. So SigStore is an example, or the GNU Toolchain Initiative. But then there's a lot of places where there's projects hanging off working groups that, but I mean, SLSA's like got a lot of mass, you know, so in some ways the Supply Chain Integrity Working Group orbits around SLSA rather than the other way around. So I'm not sure how to, but that's a good point. I hadn't thought of that. I don't think I had thought of the question of like, is it charters all the way down, or what's the dealio? Or whether it just hangs off whatever the working group has, whether the working group defines, in fact, who are the maintainers for the purposes of the CSL. This concludes my ramblings.
Yeah, I think what Mark just posted in there, I do think we should just bump this up to OpenSSF, the TAC level, because it's a fairly common thing throughout a lot of the conversations we've had, because also I know one of the other big conversations is just around, hey, we have a lot of different working groups that all sort of, you know, how does the secure repositories group differ from this other group, differ from this other one, and what does that look like? And so there's a lot of, I think, open questions on some of the governance stuff. I think it's probably worthwhile to bump up.
I can take that action item.
Cool.
I mean, there are a lot of discussions currently around the governance structure, and some of these questions I think will be answered eventually. So given that you've been living without any of this until now, I think it's okay to just keep going that way until things are clear.
Cool. Oh, I guess next up is me, unless there's any other questions about this. Okay, so I am going to share my stuff here in a second. All right, so I want to show off a couple of things of how you can use SLSA attestations that are stored in Recore to build out your sort of supply chain graph. So assuming you build a thing and you rely on some dependencies and you're accurately putting those dependencies in the materials, how you can then begin to sort of build out a supply chain graph, and you can potentially use policy and whatever to sort of assert that, like, hey, is everything in my supply chain, you know, things I trust and so on, assuming everything is using SLSA. So I ran a Nix build. And, you know, some of this is POC, so some of it is not stuff I literally built. I just sort of took the metadata that SLSA did and sort of signed it with my key just to sort of build a POC here. And so I'm just going to run this. It takes a few seconds to run, but pretty much what it does is I look up this hash in the Recore transparency log, download any attestations associated with it. and then look at the materials in those attestations, and then recursively follow that. Say, hey, do I see, for its dependencies, do I see salsa attestations? If I do, great, pull those down and keep going until I can't find anything else. And so if I go here and now open up that graph, and so this is just, I believe, XZ, the program XZ. And if I go in here, and let me go and format it. So it pulls down all the attestations associated with that supply chain. So, hey, for XZ, these are all the packages that were used to sort of build it. And then down here are sort of the graph, right? Like, so this hash relies on these hashes. These hashes don't have any dependencies, or at least no found dependencies, and so on. And so then if I go in and I have a thing that will just go out and generate a graph viz of it, I can now see, it's, once again, graph viz is not the greatest at the layout, but you can see here. So I have XZ, XZ relies on this, which is pretty much the source. And so the .drv is kind of like sort of just saying, it's not that I just rely on the source, that this sort of relies on the source. It actually relies on sort of the build of the source. So this is what that is. And I can actually go through and look through here. Like it also relies on this bootstrapping build. It relies on a builder.sh script. It relies on some bootstrapping tools and so on. And so I can see, somewhere down the line here, it relies on glibc. There's some patches it uses, and so on. And so this sort of thing that, I think is sort of valuable is like, hey, as we sort of build out the salsa ecosystem and more people are generating salsa attestations, we can start to follow those salsa attestations to kind of better understand our supply chain, and then be able to say like, hey, do I have, is everything in my supply chain using, keys I trust or whatever? So this is just something what XZ looks like. But now, just to kind of show you maybe what some of the issues in this looks like is, I'm not going to run it because it's going to take way too long. But let me show you what a hello world program sort of looks like 100% from all the bootstrapping and everything. This is what that graph looks like. It would take, I think, 5 or 6 minutes to recursively go through Recore to pull down the hundreds of attestations associated with it. But you can see here, it's like thousands and thousands of lines long. And, there's tons of edges between all of this because it's literally going out there and seeing that, at some point in time, it needs to look at, a bootstrapping compiler and all that great stuff. And to also show you one of the issues here, and hopefully this shows up good. It might be a little hard to see. Can you see sort of my thing there? Awesome. Okay, so this is the Unix hello program, right? So Unix hello relies on the source of hello. It relies on, hey, I need mirrors to know where to pull down code. So it relies on that. It relies on all sorts of, and to be clear, this is what's required to actually pull everything down and set it all up. So at the end of the day, some of the stuff for the compiler relies on awk, and it relies on, the standard Linux environment, which also relies on a bunch of stuff. And just to kind of give you an idea here, this PNG here is over 40 megs. And, here is what that sort of entire graph looks like. And it looks like a mess. But, this is sort of the thing that I think folks don't necessarily recognize, that like this doesn't just include the libraries that were used to make up the that hello program. This also includes the compiler and the compiler's library and the compiler's libraries, and so on, until you have like a until it goes to just like the default binary bootstrapping stuff. And so all of this is used to sort of make all of that. And, most of the stuff sort of falls under this bootstrap stage 0 glibc, and so on. But anyway, this supply chain query tool that I wrote up, and I hopefully plan to expand, the idea behind it is, hey, if we're all starting to use Salsa and we're all pushing to, let's say, Recore, or we're pushing to the attestation to OCI or other package repositories, we can start to go back and recursively query those Salsa attestations to go and build out a better understanding of our supply chain, to then make some of those future policy decisions. Cool. Also, I saw, I saw a couple of comments. Yeah, so I did try out a couple of the different layout engines, and a lot of them also still come out really gross. Some of them, it's just all overlapping, and I think once you have whatever this is, which is I think thousands of nodes all connected, it kind of becomes a bit of a mess. Jacques?
Yeah, I guess my first thought is slightly tangential, which is, as this kind of thing becomes more popular, it's the N+1 query from hell.
Yes.
We might want to signal to our colleagues in SigStore that this is in their future.
Yeah, so actually a couple of things on that note. One is I had to rate limit myself because I was starting to run into issues querying Recore too much. There's also other problems which were brought up to SigStore as well, which is there's a big problem with, also, let's say I have an attestation. I just say only look for attestations against these keys, right? Even if you do that, there's the potential where you might have the same attestation for the same key, right? Or sorry, different attestations for the same key. And that also creates a bit of a mess, because you might say, oh, I have an attestation, but then when I build it in the future again, or if I reattest it in the future, there's going to be definitely some issues there as well. Sean?
A quick, sorry.
sorry.
Can I ask a Dorothy Dixer? Are you aware of anyone who suggested that we need a database for this that's suitable for querying?
Almost like a universal asset graph of some sort.
Yeah, that's a catchy name.
Yeah, so there is some discussion. This is some of the stuff that I've been working with Brendan Lum from Google and Santiago from Purdue on some of this stuff. There's definitely things that'll probably have to be caching, and so one of the ideas behind this is, hey, maybe we run this query once, cache it, and then do stuff to sort of refresh that cache. Obviously, that's going to have its own quirks and issues. But yes. Sean?
So, I mean, this is doing a great job of capturing the build closure of the artifact that we've got up there. I wonder whether there's a version where we could just capture the runtime closure of something and use it as a way to bootstrap building SBOMs.
Absolutely. And I think it's something that when we are looking at the tools that generate Salsa attestations, we'll have to think about how we define those materials, or how we define the builder elements. Because right now in here, I've also included the builder elements, not just what's included at runtime, to just show, like, if you wanted to include everything, this is literally what your supply chain looks like. And just to kind of give an idea real quickly, one of the things I noticed in a bunch of the stuff, and this is something that was brought up, if you want to compromise the supply chain, go after regular expressions. Everything relies on regular expressions libraries. Everything. And so if you wanted to mess some stuff up, you attack that. But anyway, Tom?
Yeah, so if I understand correctly, this this includes not only the things that are statically linked into the library itself, and not only the tools that were used to generate the artifact, but it also includes basically what we would call the build service, right? Like hey, it needed to fetch things from this location, and so it has curl, right? My my understanding is that at like higher salsa levels, that those fetching operations, that would be the responsibility of the build service. And my intuition is that that stuff should not be included in the materials at the higher level. Do we generally have agreement on that?
Yeah. So I'm not just following the materials. I'm also following the builder just for this specific sort of use case, just to kind of show, oh, geez, like where, like if you really wanted to understand everything and how potentially, assuming, let's say you don't trust your builder for a second and you want to validate that your builder's using all the right libraries, that's what this would look like. Jack?
So just a point on that. If you're using a builder and say your builder does go and grab mirrors or something, right? Maybe you don't want that to be part of the attestations or a dependency that you want to list. But fundamentally, if you're building in a hermetic environment, it's not going to be able to go get those mirrors, or it's not going to be able to go get these resources. So that's why with Nix, anything that is a remote thing needs a fixed output, and that's the only way you get network access. I'm not sure what other solutions people come up with, but yeah, if you have a builder and it needs something, you might want to know what that something was. I don't know.
Yeah, no, definitely agree with you there. There's some interesting also sort of insights into sort of how Nix does certain things that I think is just things that we might want to just think about, because like to some extent the way that sort of Nix works is like their way of, it's like you rely on a build, you don't necessarily rely on a package, and you just sort of, if somebody says, hey, I built this thing and I'm sort of asserting that I built it a certain way, you could just sort of pull that down based on that. So there's some interesting stuff there. And then, yeah, the way that sort of Nix also works is, you have to sort of specify the hashes of the source and whatever that you're sort of pulling in, or get that through some other upstream build. Cool. The other thing, so I put in the document, the code for my SCQ tool, which is the supply chain query tool. The reason why, so one of the things just to kind of highlight real quick, one of the reasons why I did it also this way is there's not many, if you look at Recore, most sort of salsa attestations are just at a single level, maybe a 2-level thing. So I sort of went in recursively. I built a POC to just sort of go out recursively and do all that. The other thing is I'm also so the SCQ tools there's the POC for generating all of this sort of stuff based on a Nix thing, very much POC there. And then the other thing is I have a pull request which I'm working to kind of get sorted out. Right now today, SigStore doesn't, or Cosign, which is part of the SigStore project, doesn't have the ability to attest a blob or attest just a hash. You have to give it an image. And so I have a pull request to add the feature to allow it to sort of attest, any sort of blob with any sort of hash there. Cool. And that's it. Any other questions or comments?
one thing that I'm trying to figure out with the roadmap is to pull, like one thing or for the project is to pull people together who are interested in these various projects. So that way, instead of like, there's a thing here, but like kind of make a concerted effort toward adding value. Because like Michael, you said, like this is an example of like showing like the value of SLSA and how you get to have visibility. I don't think we're going to solve it in this meeting, especially in the next couple minutes, but maybe something to think about going forward is forming like working groups or something for various sub problems. Like various folks talked about how like one of the things we want to solve and is listed in the roadmap pull request is figuring out provenance storage. That's like one example sub problem. And then we could whoever's interested in this can get together on some regular cadence and kind of come up with a design, come up with a initial prototype and actually like build something out. Just something to think about going forward in like how should we organize these type of efforts?
Yeah, definitely. I know on my end, I know from some of the folks at Google, right? I've been working with Brendan Lum on some of that stuff, and I know that there's definitely interest in. I know, like coming from very much a space of like, hey, as an end user, like somebody who's mostly consuming the stuff, what do I want to see? And to some extent, this is sort of what I want to see. Is I want to be able to see that graph. I want to be able to go in and say, hey, is everything in my graph using stuff I trust? I do want to know, for example, the upstream thing of like, oh wow, even though I don't do anything bad, even though I'm not, including something like somewhere up the chain, there is some library that's maintained by a single person, and all of a sudden they've gone silent, right? Like, well, that's a big risk, and I want to know about that. I think this sort of thing helps out there. But yeah, I'm definitely down to sort of, I don't know, working group or whatever.
Have this problem and these are the things I want to solve. I would like to move SLSA more towards that model of, because right now I think it's more of like you should do A, B, and C. And I think it would be good to explain like, here's the problems I'm trying to solve to kind of connect it to real world problems. I think that what you just said sounded really good.
Cool.
If I may if I may
interject
just 1 minute. Just don't call it working group, because there is a work underway for new governance where basically there was already working group concept. I think SLSA would become a SIG under a special interest group under the new governance structure. And so just pick another name, could be task force, whatever. I think this is a good idea, by the way, but don't reuse the same term.
Yeah, cool. Yeah, no, definitely agree on that one. Don't want to overload. There's enough overloaded terms. Okay, we only got another minute or two here. Any other final thoughts, questions? Cool. If not, have a good rest of your week, everybody, and for those who are going to KubeCon and Cloud Native Con next week, in person, stay safe and see you all in a couple of weeks.
Bye, everyone.
Bye.